Hi guys, sorry I'm not here today. My son is sick, but just because I'm not here doesn't mean we're not going to learn. So I need you guys to still do your best, work hard in your groups, and make sure we learn this stuff. You can do it. Okay, so our goals today are to use the Pythagorean theorem to find the missing side length in a right triangle. We're going to find area and perimeter of rectangles and area and perimeter of triangles. So starting off with the Pythagorean theorem, Pythagorean theorem is for right triangles, finding missing side lengths. The Pythagorean theorem is a squared plus b squared equals c squared. And we use this just for right triangles. And in a right triangle, there are two perpendicular sides. So if you find that 90-degree angle, the two sides that form the 90-degree angle are called legs. So this is a leg, this is a leg. And the longest side is called the hypotenuse. The hypotenuse is opposite the 90-degree angle, and it's always the longest side. In the Pythagorean theorem, the legs have to be A and B, and it doesn't matter which is which, and C has to be the hypotenuse. Okay, so let's take a look at these examples down below. In the first example, I'm given the two legs, so I'm going to call those A and B, and instead of X, I'm going to call that hypotenuse that I'm missing C. So I plug it into the Pythagorean theorem. 4 squared plus 3 squared equals c squared. And I put 4 and 3 in for A and B. Then I square those numbers. I do my exponents first. 16 plus 9 equals c squared. Add those together. 25 equals c squared. But I want to find c, so I need to square root 25. The square root of 25 is 5. And that would be the length of the hypotenuse in that triangle. In this next example, we are missing a leg this time. We know the hypotenuse. The hypotenuse is 13, the longest side. So I'm going to put C by that 13. And then my missing side, since it's one of the legs, I need to call it A or B. And it doesn't matter which, so I'll call 12A and I'll call my missing side B. And so plugging it into the Pythagorean theorem, I get 12 squared plus b squared equals 13 squared. And it's really important that I have my missing side on the A and B side. And my hypotenuse, I know this time. So calculating my exponents, 12 squared is 144 plus b squared equals 169. Subtract 144 from both sides, and we get b squared equals 25. And so b is going to be the square root of 25, which is 5. Now we're going to find the area and perimeter of rectangles. The perimeter of a figure is the distance around the edges, and basically we add up all the sides for any figure. So the perimeter of this rectangle would be width plus length plus width plus length. Or a simpler way to write that is I have 2 times the width plus 2 times the length. And for area, we multiply length times width. Okay, so let's take a look at an example. In a rectangle, opposite sides are congruent, so this side would also be 12, this side would also be 7. And so for the perimeter, I'm going to do 2 times 7 plus 2 times 12, which gives me 14 plus 24, which is 38. And the units for perimeter, since I'm just adding lines, are the same as the original units in the problem. So this would be 38 centimeters. Like if a little ant walked around the edges of that rectangle, that's how far he would walk. Okay. Now area is length times width. So I'm going to multiply 7 times 12 and we get 84. But area we measure in square units. Area is a measure of the space inside the figure, and we measure that in square units. So it's going to be centimeters with a little 2 for squared, or you could say square centimeters. And now for the area and perimeter of triangles. For perimeter, we're still just going to add up all the sides. For area, we're going to use the formula 1/2 base times height. And the base and the height have to be perpendicular. So we want to make sure that when we find the base and height, we're finding two lengths that make a right angle. So I showed a few cases. In a right triangle, the base and height would be two of the legs because those are perpendicular to each other. In some triangles, the height is inside the triangle, like in this middle figure right here. The height has to be perpendicular to the base, so those would be the base and the height in that figure. And then in an obtuse triangle, the height is outside the triangle, depending how you have it positioned. But in this case, the height is over here. It's perpendicular to the base if you were to extend the base. So let's take a look at these examples. In this figure, the first figure on the bottom left, we have a grid that's going to help us find the side lengths. My right angle is right here. So my base and height are going to be these two sides because they form a right angle. One of those sides is 1, 2, 3, 4, 5, and the other is 3. Using 5 and 3 for the base and height, we're going to do 1/2 times 5 times 3, which is 1/2 times 15, which gives us 7.5. And I don't know the units for this problem, so I'm just going to write square units because it's area. And for the next one, my base and height are going to be the height's inside the triangle, and the base would be that 9 yards. And so I do 1/2 times 6.4 times 9, and I get 28.8. And this time my units are yards, so it's going to be square yards. And for the last one, the base is going to be 2, and the height is outside the triangle. So we do 1/2 times 2 times 3.8, and we get 3.8 square kilometers.